Alright, today we're going to continue on with 9.7, doing more practice with evaluating the composition of inverse trig functions and doing a little more graphing of inverse trig functions. So first I want you to evaluate all of these without a calculator if possible. So pause the video and try to evaluate these and unpause when you're ready to check your work. Okay. So if we look at the first one here, the tangent of the arctangent of 36, well, the first thing I want to ask myself is 36 within the domain of the arctangent function? If it's not, then I don't have an answer. So this is. So because the domain of the arctangent function is all real numbers from negative infinity to infinity. So what is the tangent of the arctangent of 36? Well, I don't know what the value of the arctangent of 36 is off the top of my head, but I know that the tangent of that is going to also be 36. The way that I can prove that to myself, or I guess this isn't a proof, but it's an example to help you understand why this is. So think about the tangent of the arctangent of 1. Well, what is the arctangent of 1? It's pi fourths. So then this question is saying, well, what is the tangent of pi fourths? Well, that's 1. So the same thing would happen here. You could also do this by drawing a triangle. So if you draw a triangle with the information that the arctangent, or with arctangent of 36, you'll see that the tangent of that same angle for that triangle is also going to be 36. Next one over here. What is the sine inverse of the sine of 5 pi fourths? Well, first, I want to ask myself, since these are the same, or since these are inverse trig functions, I want to look, is this within the range of this inverse trig function? If it is, then it's going to be my answer. If it's not, I can still do the problem though. So 5 pi fourths is not within the range of the sine inverse function. Okay, so what is the sine of 5 pi fourths? Well, it's negative root 2 over 2. So what is the sine inverse of negative root 2 over 2? It's negative pi fourths. So my answer is negative pi fourths. Down here, what is the sine of the sine inverse of negative 0.3? Again, is this number within the domain of the inverse function? If it is not, my answer is does not exist. Since it is, and since these two functions are inverses of each other, the answer is just going to be negative 0.3. Again, I could prove that to myself by drawing a triangle. Here, for the next one, the tangent inverse of the tangent of pi thirds. So pi thirds is within the range of the tangent inverse function, so the tangent inverse of the tangent of pi thirds is pi thirds. Again, you could do this piece by piece, figure out, well, what is the tangent of pi thirds? The tangent of pi thirds is going to be root 3. What is the tangent inverse of root 3? It's going to be pi thirds. But since I recognize that I have an inverse of that function, I know that it's just going to come out to be that angle. What is the cosine of the arccosine of 36? 36 is not within the domain of the arccosine function. It does not exist. Now this last one is a little bit different because these functions are not inverses of each other. So here we just want to work it out. What is the arccosine of the tangent of 7 pi fourths? Well, the tangent of 7 pi fourths is negative 1. What is the arccosine of negative 1? It's pi. So what do we notice? Well, this is where we want to look for the patterns that I was just talking about. So if we have a function and its inverse, where the inverse is on the inside, then we want to see, is this number within the domain? If it is, then that's going to be our answer. If it's not, then the answer does not exist. If it's the opposite, where we have an inverse of that same function, and the function is on the inside now, and the inverse is on the outside, then we want to look, is the angle within the range? If it is, that's our answer. If it's not, then we just have to do a little bit of work to find our answer. So here's a summary of that. So if x is between negative 1 and 1, and y is between negative pi halves and pi halves, then the sine of the arcsine of x is x, and the arcsine of the sine of y is y. If x is between negative 1 and y is between 0 and pi, then the cosine of the arccosine of x is x, and the arccosine of the cosine of y is y. If x is a real number and y is between negative pi halves and pi halves, then the tangent of the arctangent of x is x, and the arctangent of the tangent of y is y. Okay, now let's do a little practice of graphing. So I want you to graph y equals the arcsine of 2x. So think about what y equals the arcsine of x looked like. How is the 2 going to transform that function? So pause the video, unpause when you're ready to check your work. Okay, so here I've graphed both the original function, so this would be y equals arcsine of x in green, and then the transformation y equals arcsine of 2x in blue. And so all I want you to recognize is that this is just going to be a horizontal shrink where we're going to divide the x values by 2. This is about the amount of accuracy I would expect for this graph. All you had to do was what I did in blue here. Alright, next one. I want you to graph y equals arccosine of x plus 2 and then minus 1. So again, pause the video and pause when you're ready to check your work. Alright, so here in purple I've graphed the arccosine of x plus 2 minus 1. In blue I've graphed y equals arccosine of x. So again, here the accuracy is a little bit more difficult to see because this is at a height or a point of -3 pi minus 1. That's that point right there. This point is at -1, -1. But since my scale is in terms of pi, it's a little hard to see. This is right here at pi halves, so this is at pi halves minus 1. Again, getting the general shape is more important. Alright, next one. I want you to graph y equals 2 arctan of x plus pi. So pause the video, unpause when you're ready to check. Okay, so this is my rendition of y equals arctan of x. Not very great, but this is at pi 1 pi fourths, -1, negative pi fourths. These are at negative pi halves and pi halves respectively. So I can see then that this now is my transformation. So I multiplied the y values by 2, and then I shifted everything up pi. So now my asymptotes are at 0 and 2 pi. I go through the point 0 pi, I go through the point -1 pi halves, and I go through the point 1 3 pi halves. Okay, now back to more practice of evaluating. So I want you to pause the video and evaluate the sine inverse of the cosine of 5 pi 6. Unpause when you're ready to check your work. Alright, so we should end up with an answer of negative pi thirds. So first we figure out what is the cosine of 5 pi 6. It's -√3/2. That is within my domain of the sine inverse function. So what is the sine inverse of -√3/2? It's negative pi thirds. Next one, I want you to figure out what is the sine of the arccosine of √5/5. So pause the video and unpause when you're ready to check your work. Alright, so here √5/5 is not a value on our unit circle, so we have to draw a triangle. So I use the arccosine of √5/5 to draw my triangle. I know that it's in the first quadrant because of the range of the arccosine function being the first and the second quadrant, and this value being positive. So therefore I draw my triangle here. The adjacent is √5, the hypotenuse is 5, therefore the opposite is going to be the square root of 20 or 2√5. So the sine is opposite over hypotenuse. Next, find the cotangent of the arctangent of 5/8. Pause the video and unpause when you're ready to check your work. Okay, so this one you can do without drawing the triangle. So although the arctan of 5/8, that we can't get that value from the unit circle, what's the relationship between cotangent and arctangent? Well, they are reciprocals of each other. So therefore I know that the cotangent is going to be 8/5. If you're still confused on that, well, you can draw the triangle. So again, I know the triangle would be in the first quadrant because the arctangent is positive. If I label the sides, the opposite is going to be 5, the adjacent is going to be 8. So what is going to be the what is going to be the cotangent of this angle? It's going to be 8/5. Alright, last example, write theta as a function of x given this triangle. Pause the video, unpause when you're ready to check your work. Alright, so again, this is as simple as just writing tangent of theta is x plus 1 over 10. I'm using tangent because I have the opposite on the adjacent side, and therefore if I want to write theta as a function of x, I just solve this equation for theta, and theta equals the arctan of x plus 1 over 10. So, when evaluating the composition of trig functions, inverses work from the inside out. If the values or angles are on the unit circle, use the unit circle. If the values are not on the unit circle, draw a triangle. Don't forget to check to see if the value is within the domain and make sure that the angle is within the range.